Hey everyone, welcome back to the second session on selection sorting. And in this session, we are going to look at a selection sorting example. If you haven't looked at my previous session on selection sorting, where I discussed the basic algorithm, I recommend you go back and have a look at that video before watching this. That will give you a better understanding of how this algorithm works. So let's start with this example. So we have 8 elements and let's number them from 0, 1, 2, 3, 4, 5, 6 and 7. So as I discussed in the previous lecture, we don't have to iterate on all the values. Instead, we can leave the last index from our iteration, because once these values are sorted, the last index is going to be sorted implicitly, right? That makes sense. Okay, so let's start with the first iteration, I is equal to 0. And at this point, we are here, which means our array is not sorted at all. So at I equal to 0th iteration, we are going to look at the whole array and find the smallest value and places it at array's 0th index. So if we search, we will see that 5 is the smallest value. This means putting 5 on the 0th index, which actually it is not going to change the array at all. So after our first iteration, the array is going to be like this. And after first iteration, our array has one value which is sorted. Let's do iteration second, and we are going to find the smallest value in rest of the array. Turns out that 7 is the smallest value. So the smallest value is going to be swapped with array element on the first index or the ith iteration. This means this. And after second iteration, our array is going to look like this. And after second iteration, 2 elements in the array are sorted. So this is the sorted array and this is the unsorted array, right? Now in our next iteration, the smallest value is going to go on the third index. Why third? Because we started from 0. 0, 1, 2 is the third index. And we are going to look at the smallest value in the unsorted array. So, which one is the smallest value in unsorted array? It's actually 12. So, 12 is going to be swapped with the value at index second, which is itself. So, we are going to get an array like this. And after third iteration, this part of the array, third iteration, we have 3 elements which are sorted, and this is the unsorted array. Okay. Then I is equal to 3, and the smallest value is going to go at this. So looking at the unsorted part, we see that 17 is the smallest value, and it is going to go here, and this is going to go here. So we are going to get an array and after fourth iteration we have four elements which are sorted, and this is the unsorted part of the array, right? Iteration 4, smallest value going on iteration 5th, and the smallest value is going to go on the 5th index. So looking at the unsorted part, we see that 19 is the smallest value, and this is going here. So we are going to get an array after 5th iteration which is going to look like this. And after 5th iteration, 1, 2, 3, 4, 5 elements are sorted, and this is the unsorted part. Okay. Sixth iteration, and the smallest value is going on the 6th index. Looking at the unsorted array, 25 is the smallest value. So it's coming here, and these two are going to be swapped, and our array is going to look like this. And our 6 elements after 6th iteration are sorted, and this is the unsorted part. So we have 8 values in our array, and this is our 7th iteration, which means this is our last iteration, and the smallest value is going to go on the 7th index. So looking at the unsorted part, this is the smallest value, so it's going to look like this. And after our last iteration, we will get an array which will be like this, and our array is sorted until here, and this is the unsorted part. But because we have 7 elements already sorted, the 8th is going to be sorted implicitly. So we are actually going to run the loop not n times but n minus 1 times. So we had 8 elements and we ran the loop 1, 2, 3, 4, 5, 6 and 7 times, which is n minus 1 times, and we get a sorted array. So this is a detailed example on selection sorting. I hope you had a much better understanding of this algorithm after watching this session. In our next session, I am going to do how the code will look like for selection sort, and we are going to dive into the analysis part of this algorithm. I am going to end this session here. Thanks for watching and bye for now.